Okay, so as far as for this week, I do have some content for equilibrium that we can cover. However, that's not actually on this week's exam, so if you want, we can just kind of jump right into momentum. Okay. I figured that would be the case. Okay, so... Okay, so we'll start right off the bat with a momentum problem then today. So when you're ready, I don't have it like pulled up from supplemental homework or anything. This problem's from something different, so I'm going to read it off to you, or if you need to like see it, I can email it over. So a 1,120 kilogram automobile is traveling at 15 meters per second when it strikes a 795 kilogram automobile traveling the same direction at 12 meters per second. The two vehicles bounce off of each other with no damage done to either car. What are the final speeds of the two cars? If you need me to like actually repeat those values. What? So, here, I will email it to you guys. Actually, let me see if I can do this. Let me tell you, technology, I'm feeling like really outdated right now.
It's upside down on the screen. But...
Is it? Okay, it should fix itself.
Just out of curiosity, where do you look to find these kind of problems?
So this is one of the ones that Dr. Webb gave me to do. Sometimes I'll find problems from the actual book as I look through the chapter, and then sometimes I'll find them from supplemental homework. That's where I usually prefer to find them, but...
So he does give you some that...
Yes.
Representative of something, hopefully.
Oh my goodness, if I could take like a reasonable picture. But yeah, this is one of the ones to be like a little bit more representative of the material that he wants you guys to understand from this. Okay. Okay, so we'll see if this is at least clear enough. Perfect. Okay. Let me zoom this. Okay. Can you guys see that? Perfect. That's nice and useful. Okay, so I'll let you read that, and then if you guys want to draw your physical diagram first. So with this, you don't need to quite think about that just yet. I mean, you can, make like a note of it, but you're not going to have anything for a value to work with right now. But you can put it on your diagram.
As well as like gravity and things, do we need to put that into it?
So with your momentum equation, we're more so looking at your kinetic energy. So while those things do apply, you're not so much focusing on that in your diagram. It's more so looking at the mass of each object, the velocity of each object, and then which direction they're moving and in relation to each other. Is that too small for you guys to see from there?
No.
Okay.
Well, yeah, but it's fine. I already have them.
Okay, sounds good.
Yeah.
Perfect.
Equation sheet, please.
Yeah, there isn't really one, is there?
He took it down and then he put it back up.
That would have been very.
He took it down like last Friday and then he put it back up. Maybe just adjust it.
There it is. I did not see that. Okay.
He did this like
Okay.
so my diagram is not good at
Man, the handwriting on this does not look beautiful.
What an unknown surprise. I didn't have a computer. The other day I was sitting at home and it was sitting next to my bed. I was like on my bed and I woke up and it was like on me. I was like, most people can't do this. But
Okay, so you guys all have the information for the first problem, correct? Okay, so I can slide this down. Okay, so have you all drawn your diagrams? Have you identified your variable values and variable unknowns yet?
No.
Okay,
kind of.
so I'm gonna draw my little diagram here. Give me just a second. Okay.
My struggle is just finding what equation I'm supposed to use to start, and after that, I just go.
Let me help with the diagram because that's 3 points. Show me your book.
So the biggest things with the diagram is to note your objects, to note the direction that they are moving. And with this, you'll want to note that you've got this first car, your mass 1, whichever one you want to do, is 1,120 kilograms. And mass 2 is your 795 kilograms. And noting that here at the top, showing that they're both traveling in the same direction.
That's what I have.
Okay,
Good news.
so I'm just going to write my initial velocities under those. So I've got V1 initial equals 15 meters per second. And then V2 initial equals 12 meters per second. Okay, So with this problem, it says that the two vehicles bounce off of each other with no damage done to either car. So what type of collision is this? Okay, so an elastic. Oh, let me fix that. Okay. So with this, what can we understand then about momentum and kinetic energy before and after? Okay, so they're both conserved. So we have our initial velocities, but what are our unknown variables?
The finals.
Okay, so we're looking for V1 final and V2 final. And with this, you have derived equations that make things so much easier for both your elastic and your inelastic. Do you remember the one for your elastic?
There. Half. Is that one? The half mass and velocity squared.
So that's the equation for your kinetic energy, but your derived equation for an elastic is V1 initial plus V1 final is equal to V2 initial plus V2 final. So I'm not exactly sure how he gives you guys the equations on the exam, but this equation is a lifesaver. So I would just get to know it. It's pretty straightforward. I mean,
It just makes sense. The velocity, initial, and final are going to be same regardless because it's an elastic collision.
right. Okay, so
This is the elastic equation. What is it?
so this is the derived for your elastic equations. And
So yeah, so we would have to
perfect. Got page 2 of 2 now. Maybe it'll load. Okay.
Do you, so from this point, do you just like pretty much put in what you know and then solve what you don't?
Yes.
There's two unknowns.
So, like we've done with some other equations, you are going to
Plug in the
be,
unknowns you want.
yes, plugging in and manipulating. Okay. This should be good. Okay, so for our V1 initial, what was that value?
V1 initial is 15 meters per second.
Okay. Plus, we don't know V1 final yet. Is that equal to V2 initial was 12 meters per second. Plus our V2 final that we have to find. Okay, so how would you guys like to solve this?
I think we should put all the unknowns to solve for V1 final.
Okay,
I'm just thinking.
so
You know the beginning, you know the end.
that works. So if we solve for V1 final, then we're going to subtract 15 over.
Then you have a negative number. If you do it the other way, then you have a positive number.
Either way though, because you have to move the negative, the 12 also.
Maybe you're just figuring out the positives for that side, so the negatives for that side.
What do you guys want to do? Do you want to solve for V2 final or V1 final?
That's easier.
It's up to you.
Okay, let's go with the positives then.
Okay.
Yeah,
So-
just focus on the positives only.
I know, I'm trying to, but I didn't realize, like, either way, I saw, like...
Either way, you can do it either way. I'm just saying that you have a negative.
You can do it either way, but yeah. I see the thought process.
So that
Oh,
kind
okay,
of-
yeah, I see
that
now, I
kind of
see
makes
it,
it a little bit
I see
harder.
it, I see it now.
Okay, so now you have
I also didn't want to erase it.
3 meters per second plus V1 final is equal to V2 final. Okay, so we're stuck now. We have 2 unknown variables. Where do we go from here?
Can we do force equals mass times acceleration kind of thing? Is that even a thing?
So we don't have an acceleration.
So,
We got the velocity.
Don't know a force.
The
can you
velocity
find the
acceleration.
momentum now, though? With
Yes.
E equals mv?
You'll want to use your momentum. Because you know that momentum is conserved,
Yeah, I see.
and you know that kinetic energy is conserved, you're going to utilize those equations to get your before and your after.
Right, wow, so it's...
Okay, so
I think you
Well, I don't know, I just... Oh, I see that.
so what's our equation for momentum?
P, which is momentum, equals mass times velocity. So
Okay.
P is a momentum, right?
Yes.
What?
There we go.
That makes a world of a difference over here.
Okay, so what is the equation then for our initial momentum?
I'm sorry, I already have the answer. I just did it. For your initial,
Yes.
wouldn't we find the initial momentum of both car 1 and car 2 by just timesing the mass times the velocity for each one?
So yes, so you'd set up P1, or sorry, let me back that up. P1 equals M1 V1, and P2 equals M2 V2, but you want to find the sum of P1 plus P2. So then you can just set it up as M1 V1 plus M2 V2. And then this will equal your P initial.
Oh, yeah. I'm understanding. I like that.
Does this make sense so far?
Yes.
Okay. So this really kind of touches on that concept that we talk about in theory, understanding that your momentum is conserved. To be able to utilize your momentum equation in this to get your initial velocities or to go from initial velocities to final velocities, you have to understand that concept to put it into equations.
If it was inelastic, it'd be way
Be a little bit different, but we're going to do that too.
Okay, good.
Okay.
So now we can throw our stuff in here.
Yes. So we've got 1120
The answer.
and always keep your units. I'm not going to, for the sake of writing on this, but keep your units. Don't take on my bad habits.
Is it kilograms,
And then meters per second.
divided by meters per second?
So you've got your 1120 kilograms times 15 meters per second plus 795 kilograms times 12 meters per second. So if someone wants to calculate that for me, make sure we get the same numbers.
Do you have 16,800 for the first one and 9,540 for the second?
Yes, that sounds about right. I just did the total of them.
Yeah, oh yeah, 26340.
Yes. Okay. So our momentum initial is 26,000
And this
340
momentum is kilograms.
times meters per second. Okay. So then we have to find still from the beginning. So let me kind of pull that back so you can see everything that we've got. Okay, so we have this equation up here of the 3 meters per second plus V1 final equals V2 final. And we've got our initial momentum. So now where do we want to go with this? What do we know about our initial momentum versus our final momentum? Okay. So our final momentum would be utilizing final velocities. So we can set up,
Oh, so technically our initial momentum is the same thing as our final momentum, which means that our final momentum is the same thing as our final velocities.
yes, basically we can derive our final velocities from that.
Yeah.
Okay, so we'll set this up and we'll have M1 times V1 final.
Can you explain that again?
Okay, so your initial momentum is equal to your final momentum. When you look at the actual equation for momentum, it's mass times velocity. So you take for your initial momentum, it's mass times the initial velocity. Yeah, and then final momentum is thus mass times final velocity.
Makes sense.
Okay, so then we have mass 2 times V2 final. Okay, so now we can solve for this. So to solve for this, give me just a sec. Okay. So we're working with the equation here at the very top, the 3 meters per second plus V1 final equals V2 final, and we're working with this bottom equation.
You can just plug in V2F,
Yes.
that in for V2F.
Okay, so we've got 26,340 equals 1120 times V1 final plus 795 times, we had 3 plus V1 final. Yeah. Okay, so what's your next step here?
Start consolidating and put stuff together.
Okay. So how do you want to consolidate first?
I did my 795 times my 3. That's like the easiest for me to do.
Yep, that's appropriate. So I can go through and write this out in the step by step. What did you calculate for your 795 times 3?
2385.
Perfect. Plus 5v1 final. Okay, so now what?
Start dividing out.
Okay, so we'll factor out our v1 final. Oh, whoops. I did not mean to keep that 795.
But it does have to distribute into the 795.
Oh, yeah, sorry.
But wouldn't you just combine the one, the
What did I-
1120 with the 795?
Let me go back.
Yeah. Yeah.
That's what I did.
Yeah, that's a good idea. Instead of pulling the VI out.
Yeah. I just got carried away.
So right now I have at 1915 V1 final plus 2385 meters per second.
Perfect. That's what I have here.
Okay.
And then we can
Okay.
subtract that over.
$19.15. Sorry, give me just a second here to get back to my stuff. Okay. Pull up my calculator. Okay. So we have our 795 plus our 1120 for our V1 final. Plus, said 2385.
Yeah.
Okay. So now we can subtract this from both sides.
Yeah, but once you subtract, then you can just divide by that 1915.
Right. So what did you get for your value here? 26.
Well, I'm just confused because the 263040 is kilograms per meter second, and you divide by meters per second.
So here, this is technically, this 3 right here is still a meters per second.
Okay.
So you've also got your kilograms here and your kilograms here, and you're going to subtract that over.
So does that collapse? The 26340 would be minus 23085? Like that would be one number together?
Mm-hmm.
Because I was just confused
Yep,
on
so
the
if-
units.
Okay, so if I were to do this and write it all the way out, you'd have 1120 V1 final plus 795 V1 final plus 2385. So then you would collapse your V1 final values to get 1915 V1 final
I got,
plus 2385.
uh-huh.
And then you'll subtract that over.
Okay. But is that independent of the left side? Like I'm like 26340 minus 235, or and then it collapses even further?
So you're going to subtract your 2385 and we're going to divide over the 1915 to find our V1 final. Okay, so what did you calculate for your 26340 minus 2385?
Yeah.
23955?
I don't know why I'm saying it.
There we go. Okay. So now we can divide this over. So then we have V1 final equals 12.5. And that's meters per second. Okay, so let me condense this.
So you only have to find it for the initial final.
So we're going to keep going, yeah. Okay, so we had 3 meters per second plus V1 final.
So we can just throw our V1 final into that. And
Yes.
your V2. So did you get 12.519?
Okay, so we can keep that out to 5.1 for now if we want. So let me zoom back. So we've got, back into that equation, we have 3 plus V1 final equals V2 final. So we plug this in, is 3 plus 12.51, and that equals
1551.
perfect. Okay, so V1 final that we were looking for is 12.51 meters per second, and V2 final equals 15.5. Oh, that was very squiggly. 5.1 meters per second. However, if you go back to our actual problem and look at the significant digits, we'll want to adjust that answer. What'd you say?
Should only be 2 significant digits, right?
I think we had
15. Or
3 on each of those.
Oh. So
Yeah, perfect.
So 15.5.
Yep, so we're going to change all of those to 3 values, if I can ever get back. No, come on. Okay. So when we look at the second aspect of the equation, let me go back and pull it for you. Getting used to maneuvering this is still weird.
So now we're going to do it as if it wasn't inelastic.
Yes, so the actual, once this loads you'll see it, but the actual next part is, suppose in the previous problem that the bumpers had become stuck together during the collision. What would the final speed be for the 2 cars?
By the way, that makes a lot of sense.
Yes.
Okay, good.
It felt good, and it felt like I was very smart.
I'm glad. That's what I like to hear.
What's the thingies again? Sorry.
The what thingies?
Like the velocities or.
Oh, okay. So the mass one was 1120. The V1 initial was 15. The M2 was 795, and the V2 initial was 12.
Oh, the same.
The what?
The same thing as last time, but this time
Yeah,
it's stuck together.
but this time it's just an inelastic. Yes. So, what do we once again understand about the inelastic?
The energy is not conserved.
Energy is conserved, but kinetic energy is not. Or
So-
momentum is conserved, but kinetic energy is not.
Correct.
We're there.
Momentum is actually conserved, kinetic energy is not conserved. So, very simply, we are looking for the final speeds of the two cars. So, what can we understand easily about that?
But the two speeds would be the same.
So,
That's hard because I want to lump everything, velocity, acceleration, momentum, all into one. The same.
okay, so if they are stuck together, their bumpers are stuck together, they're moving then together.
Right.
So, their final momentum is going to be, how would you calculate final momentum at that point?
Would you add the momentum of both of them and have it equal your starting momentum?
So, yes, but what would the equation look like for adding their momentum together?
Sum of the momentum equals mass.
So, if they're stuck together and they're moving together, what is their velocity going to be like?
A summation of the velocity.
So, basically, is what I'm saying.
The
Is there...
half velocity and half
Nope.
Nope. So, I'll make this very simple. Okay, so their final momentum is going to be their combined mass times velocity because they're moving the same velocity
Right. Okay.
since they're moving together.
We have to find out the velocity. 'Cause we don't.
So we're going to have to find their final velocity together. But doing that, we already know from the first part the initial momentum.
Right.
So we have P initial equals 26,340. Is that what?
So it's
Okay.
the combination of mass 1 and 2 summed together times the velocity.
Yep, you got it. So
Velocity of what?
P2 equals mass 1 plus mass 2 times V. You could note this as like V1 and 2 or V total, however you want to denote it, really. So I'll just put 1 and 2.
Is total and net the same thing, just vocabulary-wise?
That is like
I mean, it can be, but like not exactly in this sense.
Okay, I was just curious because
I mean, you have to, total and net can be similar and like, I don't know, changed out for each other, but not in every sense.
also another concern I have.
Yes.
When do we use the little vector sign so I don't get points off on my equations?
So, momentum is a scalar. With your...
Vocabulary words.
So, your momentum is then at that point just a magnitude. Your velocity, I mean, in general, you can just always note your vector over it if you're, worried about like the writing out of your work and whatnot. I mean, beyond that, it's pretty much what we've done so far as like forces having a vector, velocities and accelerations having a vector, that kind of thing, displacement. Okay, so I lost my page. There we go. Okay, so now we can plug in for this. So we know that P initial, it's not what I meant. And P final are set equal to each other. So then we have 26,340 equals M1. We'll actually just plug in our values at this point. 1120 plus 7 95.
But are we, the P final equals the M1 plus M2, so we're just plugging in the P initial? Right, oh, because we're assuming that they're the same thing.
Yes, we're
Because
assuming
momentum
that
is conserved.
we're assuming our momentum's conserved, so we know that P initial should equal P final. So then we can plug those equations in for each other to be able to solve for one variable.
I have to see the big picture before I can see what's. Oh, why did I do that one?
Because now that it has a number in front of it, it acts, you have to get the B.
Oh, you
this
just
to
added,
get the-
she added 1, 2, 0 plus
Yeah.
Oh.
And then she just skipped the step, she just divided by
Me,
1950.
I don't see every step.
Did what?
You just skipped the step in a sense that
Right,
you didn't add the what's in the parentheses together. You went straight to divide.
Oh, yeah.
1915. No, I get it.
Sorry, I do that for some odd
You're fine.
reason. My brain just like, I don't know.
You're fine. I just that did not like. carry-
Understandable.
Got it. Okay. So now we found our velocity, but we know the velocity combined and not separated. Or did they want us to find the velocity?
So your final speed for the two cars, since they're connected to each other, is going to be the same.
So that's our final answer.
Yes.
Awesome. That was way easier technically because we did the first one.
Yeah. Once you go through it for the first one, and then if you like do your elastic and then your inelastic, you've done like all of the work basically.
Okay.
But I mean, if you just had like this question standalone, you'd have to do the whole process for finding your initial momentum as we did. Yes.
So is this section considered the not the last section of the test, but the middle section?
Synthesis, you mean more like application version?
Yeah.
Or,
So
one-step problem ones. Yeah. Not really because.
Because I mean,
There's no way this is.
because synthesis problem
Did you see
is
how
like you
much-
have to think and combine everything, and this is only one thing. So can you go over this on Monday because I can't attend tomorrow.
So I'm going to record them, so then if you watch them over the weekend. But this should be, I'm honestly not sure how he'd do it.
Because that's my only concern, like, how far do I need to like stretch my brain to think physics? Because he says synthesis
Right.
is where you do all the physics, which is physics is pretty much
Do all
math.
the
You
physics.
do all the physics?
And then application, he said it's just math problems. But I feel like those are the same thing.
I'm honestly not sure how he'd go about this one. I couldn't tell you. But we've got one more part to this. So we're going to try and get through it as much as we can. So the last part is how much kinetic energy was lost
Oh, yeah, this
when the cars stuck together. And then where did this energy go?
it translated into friction.
Okay, so
Action's like,
Was
oh.
it, how much was kinetic energy lost? by the
so
cycle?
how much kinetic energy was lost when the cars stuck together? Okay, so what do we have? Mm-mm. Okay, so what's our equation for kinetic energy?
Okay, hold on. I'm pulling
No,
it
you're
up.
good.
Velocity mass times velocity squared.
Okay, so with this,
1/2 mass times the velocity squared.
you got it. Okay, so we have to understand that we're now comparing our initial kinetic energy to our final kinetic energy when they're stuck
So
together.
can we assume that the summation of the initial and final equals 1/2 mass times?
So both the masses together.
So you have to do the sum of the kinetic energies from the initial.
Yeah.
So you have 1/2 mv.
Would the m's be the masses together too?
So I'll write it out separately first.
Sounds good.
And then
I know.
We gotta keep on again.
okay,
Jumping off. We'll be sucking the vortex.
But there's room for both of us.
That's right.
The
I will pull audio on you.
oh, well,
Oh, yeah, you're right.
okay, so you can condense this. For the sake of this purpose, I just left it all straight out so that, especially for those that are just like watching the recorded versions, that they don't lose where variables go.
Yeah.
So I just straight plugged everything in.
I'm
from here.
confused as to how we just add them together and they just equal it. Does that make sense? Like the 1/2 mass velocity squared. Like how can you just say that plus it in the second car sense is going to equal kinetic energy as a whole?
So basically is what we're looking at is we're looking at the total kinetic energy of the two cars in the beginning. So we have to understand that our total kinetic energy, like if we were discussing an elastic, we would understand that the total kinetic energy between car 1 and car 2 in the beginning would equal the total kinetic energy between car 1 and car 2 in the end.
Right.
Since we're inelastic, we know that they're not conserved.
Okay. Yeah.
So we're
Wait,
looking...
how did you know that you have to do it twice? Or like the 1/2, if the equation is just the 1/2 and b squared?
Because
So
the
the two-
actual, if you were to do the sum of your kinetic energy, it would be kinetic energy 1 plus kinetic energy 2, and then you'd have to plug in for each kinetic energy your equation.
Which is that. So
Yeah.
this is just a simplified version.
Yeah.
Okay, that's kind of what I was asking.
Oh, okay.
So that makes okay. Yeah.
Good. Okay, so
So like if there was a 3-car pileup, it would be 3 of them?
so
Okay.
you do this for
9, I'm getting
yeah, perfect.
Got you. Okay.
Okay, so then I just kept it all out and just simply plugged everything in. And then our V1 was 15 for car 1. Okay, so let me know what you guys get calculated.
So for the first one, 126,000.
Okay?
Is that right?
Yeah,
Yep.
I got that.
57,240.
Perfect.
1,240? Yeah. I got a total of 183,240.
Perfect.
And energies in joules?
Yes.
Which one's work is the Newton's one?
So work is your force times your distance. So
It is.
what?
Work is in newtons.
Work is your Newton meters. Mm-mm.
Newtons times meters. So now we have our joules, which is how much kinetic energy was lost.
So this was our initial kinetic energy, but we want to understand what was lost. So we need to then look at our final kinetic energy.
Jeez. So much stuff.
I know.
Ugh.
I don't make it easy on you.
Okay, one question.
So how would we calculate our final kinetic energy? Okay, so what would that equation look like?
So adding the masses together.
Yes. And then we have our V final from our last equation. And I had 13.8 meters per second. Here, let me back that up.
Where did you get the number from?
Oh, yeah, okay, I'm understanding.
What?
13.8.
So the 13.8 was from our number 2 of this process when we looked for the final speed for the 2 cars. Because right now we're looking at the kinetic energy for the 2 cars after they've collided and stuck together. So their final speed is what we had just calculated. Because right now we're looking at final kinetic energy. Does that make sense?
Yeah.
Okay. So now we can plug this all in.
Oh, your eyes.
Okay, what did you get calculated for your kinetic energy final?
13,213.
That's not right.
Did you lose a half? Because the masses together should be 19.
Did you do 13.8? Or 13.75?
I used 13.8 because we put it to the significant
That's why.
digits,
I didn't do that.
and then multiplied that by some of our masses, which is the 1915.
Yep,
Times
I just didn't do it
0.5.
by 13.8, I did it by 13.75.
Oh, okay. Perfect. So then what did you guys get for your value?
13,213.5.
You're still off somewhere.
That's what I got too.
Did you did you square your velocity?
Oh, nope, forgot. I dropped that.
That's crucial. That will make a drastic difference.
I dropped my,
You will lose some kinetic energy, but not quite that much.
that's me.
Ooh, yeah, there you go. Answers.
Yeah, I was like, why is it so much?
That's really a lot. $182,346.
Yes. That sounds way better.
Yeah. This one?
894 joules. Now we need to determine where did that go.
82.
Bye-bye.
Okay, I have 894 joules as well.
Loss in heat, yeah. Because kinetic energy, well, energy is energy destroying.
So we've already got this into our 3 significant digits, so we know that this is our kinetic energy lost. Where it goes is, so basically when you think about the 2 cars coming together, there's a transfer of like thermal energy, so you've got like heat and a couple different aspects. But basically it deals with the damage to the car, so you have to put some sort of energy in to cause the damage on the bumpers to be able to condense those. There's also like a mechanical energy in there, but it's really looking at that energy that is causing the condense of the bumpers. Okay, any other questions?
No, that was very helpful, and it seemed way easier than what I was.
Good, I'm glad.
Thanks, Ashley.
Of course, you are so welcome.